talking to a person who says, there's nothing but your brain. There is nothing else. So I ask him, well, what is a toothache? What is a hope? What is a panic attack? What are they? He says, they're things happening in your brain. That's what they are. I say, okay, that's interesting. Can you tell me why you think that? Why do you think that these things are events in the brain? All he can tell me is there is a very well-established correlation between what happens in your brain and what you experience. That's all he's got. It can be a gross correlation. It can be a correlation down to details, structure, and all the rest. He's got a correlation. I say, but look, correlation is not the same as identity. You can correlate two things and they remain two things. They don't become the same thing because they're correlated. Thunder and lightning are correlated. You could have, this isn't really true because it's oversimplified, but you could have a correlation between the wavelength of the light that hits your eye on the one hand and your experience of color on the other hand. The wavelength of the light hitting your eye, the light in space that hits your eye, and your experience of color. Nobody thinks that the light in space is your experience of the color. Nobody thinks that. Even if they're correlated, nobody thinks that. They're correlated. They correspond to one another. That doesn't mean they're identical. So I say to the believer, the materialist, I say to him, I need more than that. Correlation isn't enough, not even detailed correlation. It's not enough to convince me that they're the same thing. Now, I suggest to the believer that there is a way he could satisfy me. After all, science has in the past discovered identities, not just correlations, but identities. Why don't we take a look at places where science has been successful in establishing identities and see if we could transfer the same method to the case of experience and the brain. If we could do that, maybe there would be good reason to think that experience just is what goes on in the brain. Take where it has been done successfully, where it's recognized and it's admitted it's been done successfully, and try to do it over here. Seems like a reasonable strategy. Well, where has it been done successfully? It's been done successfully a number of times, a number of different areas. I gave two examples because I think they're different in their style. And I think it's important to get clear on what kind of style we would hope for in the case of experience of the brain. One example was sound, the other example was water. Sound, and by the way, what I'm telling you at this point is gospel. This is very many philosophers say this over and over again. How does sound work? Well, if you think back 300 years ago, what do people know about sound? People knew a lot about the way sound behaves. They knew what kinds of things cause sound. They knew what kind of effects sound has on other things. They knew a lot about how sound behaves. They just didn't know what it is. They didn't have a clue what it is. Now, if that sounds mysterious, let me give you another example, which may be more familiar to because you've been polluted by prejudiced education. Think about genetics. Mendel in the 1830s did experiments which make it clear that the characteristics that offspring have are related in a certain systematic way to the characteristics of the things that they spring off of, the things that they come from, pea plants and other things like that. Obviously, there's some connection. The size, the color, the shape, the number of leaves, and so on and so on, in the parent plants is reflected in the offspring plants. What does that? What does that? Where are these traits held? How are they carried? How are they transmitted from one to the other? What's doing the transfer of these traits? No one had a clue. No one had a clue. No one knew for sure, and even now it's contested from another direction, that was the DNA till after Watson and Crick in the 50s. So you could see there was a correlation. If you believe that the world is governed by physical laws, something's got to be doing it. But what is it? No one had a clue. Similarly with sound, we knew what kinds of things make sounds. We knew that sounds could be contained in very tightly sealed containers. It doesn't get out of a sealed room. We knew that it bounces off walls. It certainly behaves like a physical thing, but what physical thing is it? 300 years ago, no one had any candidates. People just threw up their hands and said, well, got to be something there, but we haven't a clue what it is. Now we say science discovered that it's patterns of hair waves when the sound is going through air. Patterns of motion of the air. Why? Maybe it's little green leprechauns leaping from the snare drum to the guy's ears, or something else. Maybe it's, electromagnetic fields. Who said that it's the pattern of motion of molecules of air? Who said? Why did they say that? The answer is, when you look at all the things we know that sound does, and you ask, will these airwaves do those things? The answer is yes. You could show in detail that airwaves will do every one of the things that we know sound does. Have a tightly sealed room, bang a drum in the sealed room. The airwaves get set up, but the walls are too solid to let the airwaves pass. They're too solid for the airwaves to shake the walls and have airwaves on the outside, and you can measure that. So you see, if it's airwaves, you understand why it's contained in a closed room. You understand why the sound dies away at distance, because when you bang on a drum and the air starts shaking, the air to shake takes energy to move the next layer of air, the next layer of air. That energy runs out. That's why it gets softer and softer the further you are away. Why does it bounce off a wall? Well, these airwaves have a certain structure, and when they hit a solid object, they bounce. So you can explain echoes. Why do you have an auditory experience when somebody bangs a snare drum? Because the airwaves bang against your ear, and your ear has in it very, very delicate structures that are sensitive to airwaves and set up neural impulses that are a result of that. So I now know why banging the snare drum causes at least the brain events that are associated with the experience of sound. So when you talk about airwaves being identified as what sound is, what you're saying is, I start with what people call a functional description, but maybe the word behavior is even better. I start with the description of how sound behaves, and that's all I know. All I know about sound is how it behaves. That's all I know. I don't know anything else. Then somebody says, hey, look, Q will do all those things that your description of sound says that that's how it behaves. Q will do all that stuff. That's when science says, okay, then Q is sound. Is this infallible? Probably not, but it's a good reason. I'm inclined to agree. That's a good reason to say that Q is sound, and that's what you have with airwaves vis-a-vis sound traveling in the air. That the sound in the air is the motion of the airways. Are we together so far? Okay. Notice this is not just correlation. This is not just correlation. It could be that wherever you have sound, the air turns purple. You would not say purple color is what the sound is, because the purple doesn't obviously stay inside the walls. Purple color doesn't obviously bounce off walls. Purple color doesn't obviously get weaker and weaker at a distance. Purple colors don't have to do any of that. That wouldn't explain anything. Then I would just say it's associated effect. It's not what the sound is. It has to explain why the thing does what it does. That's one type. And there are a lot of other examples of the type. Heat. What is heat? There was a time when people thought heat was a liquid. Hot things have this liquid. Cold things don't. The reason why, when you put a hot and cold thing together, the heat, as we say, flows. That's the word we use. We say the heat flows from the hot thing to the cold thing, is because they thought of it as a liquid. They put it together, it can move from one to the other. That turns out to be dead wrong. Turns out to be dead wrong. Hot things aren't heavier than cold things. Not until you get to atomic scales. So it's just wrong. It was a thought and it was wrong. Fluid can't explain what heat does. Random molecular motion can explain what heat does, and therefore they say we discover what heat is. Random molecular motion. Fine. There again, with heat, you knew its behavior, but you didn't have a clue what it is. You discovered that random molecular motion does all that stuff, so then you say that's what heat is. That's one type of identity. Another type of identity is water. In the case of water, we also have a description of how it behaves, things that it does, what causes it to behave in various ways, and what effects it has on other things. But in addition, we have samples. We have actual samples of water. No one can say, I don't know what water is, where water is, what kind of thing it is. We have glasses and oceans of it. So now, if somebody wants to tell me that water is H2O, he has a double job to do. First, he's got to show me that H2O, molecules of H2O, will behave the way water behaves. He's also got to give me good reason to think that what's in my glass is H2O. He's got to do both jobs. If he does both jobs, and this is in fact what science has done, if he does both jobs, then we have a right to conclude, again, not infallibly, it could still be wrong, but we have a right to conclude that water is H2O. How is it done? Well, you take the calculation of H2O and you can calculate that at 0 degrees it'll start to solidify, 0 degrees centigrade, 100 degrees it'll start to boil, that it can nourish various living things, that too much of it can cause you to drown. I mean, all these things can be calculated from the molecule of H2O. So in terms of explaining its behavior, H2O is gold. How about the stuff in the glass? Well, if you pass an electric current through water, then what happens is the water little by little fizzles off, and what you're left with is hydrogen and oxygen. So the scientists will tell you, see, what the electricity is doing is breaking up the water molecules into its components, and since what you have left is hydrogen and oxygen, that's a good reason to believe that the water in the glass is made of hydrogen and oxygen. Also, there are certain types of conditions under pressure and other types of energy where you can take hydrogen and oxygen and make water out of them. You say, well, so you see, that's why I think that what's in the glass is H2O. When you have both kinds of evidence, that's a convincing argument, again, not infallibly, but it's a convincing argument, a reasonable argument that water is H2O. I pointed out yesterday that you need both, because if you had either one without the other, I think our minds would think of alternatives. We would not be convinced that water is H2O. Suppose that the H2O molecule freezes at 0 degrees and boils at 100 degrees and nourishes plants and so forth and so on, does all the things that water does. But try as you might with that glass full of liquid, attack it in all the chemical and physical ways you can imagine, you can't find any oxygen or hydrogen there. You just can't find it. Pass electric current through it, you get chlorine and carbon or something, or who knows what. It just doesn't come apart that way. I think then we would be inclined to say, well, H2O does all that water does, but there must be something else also that does what water does, and the stuff in the glass is that something else. It's not H2O, because when I attack the stuff in the glass, I don't get H2O. H2O was a theoretical possibility, but doesn't work out in practice. And vice versa. If I attack the water in the glass and I get out hydrogen and oxygen, but according to my calculations, H2O will not freeze at 0 degrees centigrade. I will not boil at 100 degrees centigrade. I will not nourish plants, and so forth and so on. I think what we would say is, well then, when you pass the electric current through the water in the glass, you're not just pulling it apart into its pieces, you're changing it. The electric current is changing what's there. Really, it's chlorine and carbon and iron and so forth and so on, but when you pass electric current through it, you're messing with the molecules, you're messing with the atoms, and you're getting different stuff out. We're not going to be convinced that water is H2O unless we have both parts. We have H2O doing everything that water does, and reason to think that the stuff in the glass is also H2O. We together? Okay, so now I think it's obvious. It was fairly obvious yesterday to all of you, and I think it should be obvious, even though there are philosophers who disagree. Descartes wrote, there is not an idea so foolish that some philosopher somewhere has not espoused it. Very bitter remark by Descartes. And every idea, no matter how foolish, some philosopher somewhere has taken it, has accepted it. The relationship of experience to the brain is like water. Because as far as experience is concerned, we have double information. On the one hand, we know a lot of things about how experience behaves. We know a lot about the causes of experience, and we know a lot about the effects of experience. But also, we're having experiences all the time. We know them firsthand. I don't have to go to Siberia to find, a toothache or an itch or the pleasure of drinking Coke or something. We have them all the time. So in the case of experience, in order to convince us that experience really is what goes on in the brain, the materials has got to give us good reason to think that the toothache I feel is built up out of neurons doing various things in the brain. That's what it really is. That's in addition to doing the functional job. So you got two jobs to do. Now, I said yesterday, as far as the functional job is concerned, that's pretty intuitive, even though the scientists tend to exaggerate the evidence and they make it sound more complete than it is. But it's pretty intuitive that when somebody steps on my foot and I have the experience of pain, and that results in my either yelling or getting an aspirin or punching him, and somebody says, well, what is there between stepping on the foot and getting the aspirin or punching him? Well, what's in between is the brain, because when you step on the foot, neural impulses travel up to the brain. And then the getting the aspirin or the punching is a question of moving the muscles. And the signals to move the muscles come from the brain out to the muscles. So yes, what's in between the step on the foot and the resulting behavior is stuff in the brain. If you're going to talk about how experience behaves, then it's pretty convincing that that the brain is the address as to where it's taking place. The problem is with the samples. The problem is with the actual experience itself. To show that the actual experience itself is built up out of neurons in your brain behaving in certain ways. Now, on the model of water, there are two ways to go about this. Maybe either one would be sufficient, though ideally we could do both. One is take a look at an experience and start pulling it apart. Pull it apart into its smallest pieces. Pull it apart into its individual dimensions. Reduce it down to its tiniest fragments and see that the smaller the fragment you get, the more it looks like a neuron. And you get really small fragments, you can sort of see electricity in there. You can see electricity going from synapse to synapse. The ions become visible behind the screen, so you see the ions working, so on and so on. If you could start with the full-blown experience and work it down to its tiniest elements and see neurons in those tiniest elements, you'd have an argument. Or vice versa. Start with the brain, start working up in the brain, considering the various structures in the brain, and putting it together, and thousands, and millions, and hundreds of millions of neurons fighting in various ways, until what you have is an experience. If you could do it either way in a convincing fashion, that would definitely be a reason. It would be a reason, it would be an argument, it would be evidence, it would be something that you could deal with. Now, the claim that these philosophers make, the ones that I'm quoting now, this is only a section of philosophers, is that, number one, intuitively, there's no clue how to do that. Intuitively, it doesn't work at all. And number two, there are principled arguments against discovering that the toothache is just neurons firing. So yesterday I started to explain the intuitions. I'll go back through that again. And then after I explain the intuitions, I'll start giving you some of the arguments that people have used to show that this project is impossible. Well, let's take analyzing experience, breaking it down to its tiniest elements, and see if, as we do that, we are clearly getting closer and closer to neurons. I'm sitting here. I'm having visual, auditory, and tactile experience. That's very complicated, very complex, different dimensions. Reduce it to the visual. Fine. So the auditory and tactile, we're just leaving out of the picture. Now, the visual has colors and shapes and perception of textures and relationships in space. Reduce all that. Let's just talk about color. Take something that you're looking at that has a color. Okay, but color has hue and saturation and opacity, somebody said yesterday.
Contrast.
Say again?
Contrast.
Contrast, okay. Too many variables, too many dimensions. Let's reduce it. Let's talk only about the hue. Right. Now, if I look at this table, there's a bunch of hues. So take one little spot on the table and look at the hue on that spot on the table. Now, as we make that progress from 3 senses to 1, from the whole visual picture just to color, from color to only one dimension of color. Do you see the neurons peeking out from behind the corner? That this is really made up of neurons, not correlated to neurons, made up. That the neurons are there in the hue of your experience? I don't think so. What you have is experience. It's all experience. It's a bigger experience or a smaller experience, more complicated experience or simpler experience. But you're not stepping outside the category of experience. It's all experience. Let me show you what I would mean by stepping outside. Take water. Water is a liquid, right? Okay, so now, oceans of water, teacups of water, teaspoons of water, drops of water. Fine. Keep going down. You're going to get to a certain point where what you have isn't water anymore. Individual molecules of H2O, let's say 6 of them together, aren't water. They will not flow from one place to another. They will not adhere to a surface. There's too few of them. Water requires a certain minimum number. When you get below a certain level, it isn't water anymore, and it's something else, and it's pieces with certain shapes, certain properties. So you have gotten out of the category of water because it isn't a liquid anymore. Same thing with color. Molecules have color. Some atoms might have color. Protons have no color. Neutrons have no color. Electrons have no color. Color is a function of moving an electron up to a different energy state in an atom and then having it collapse back down and release a photon. Protons don't do that. Neutrons don't do that. When you get outside the structure of atoms, you've lost color. It isn't there anymore. You got something else. Okay, I want to see that happen. You go down and down with experience until you get to a point where it gives way to neurons, something else. This doesn't do that. When you take experience and you boil it down to the tiniest pieces, it's all experience, just little smaller pieces of experience. Doesn't be any bridge in analyzing the experience to get down to neurons firing. What about the other way? Well, you go into the brain and you're building up these structures and you're seeing more and more complicated structures. Is there a point where you're going to see, find, identify the experience, the toothache in the brain? Well, there are two, aside from the fact that no one's ever even tried to do that, there are two factors here to take into account, which makes that look very, very difficult. Now I'll go back to something you said yesterday. I'm going to show you how, using the very same information, you get the opposite result. How do we identify what part of the brain is operating when there's a toothache? How do we do that? We do it by asking the guy, do you have a toothache or don't you? And when he says yes, then we look at the brain and see what's functioning. We do it by asking the guy. We do it by getting a direct report of the experience. That's the only way we know. There's no other way to know. But then that means you're not finding the toothache in the brain. It isn't as if everybody's had toothaches. Now, I just go searching in the brain and see, oh yeah, there's a toothache. I know what toothaches are, and there's one. You don't do that. You got to ask the guy himself whether he has a toothache. Why? Because looking in the brain by itself, you don't find toothaches. You only find something going on, and then you ask him, what do you feel? And you correlate. That means the fact that you have to get a correlation means you're not finding it directly. You're not finding it directly. Now, some have put this in a kind of science fiction fashion. Imagine doing this. Imagine another species somewhere in the universe that's not built like us. They talk about the possibility of life being based in silicon, or if you believe evolution, then the number of chance moves in evolution is such that you can get vastly different creatures. Creatures whose senses don't match ours exactly. I don't know, maybe like bats who don't see and look and move around by echolocation, or creatures that are sensitive to ultraviolet light and not mid-wave light that we're sensitive to, creatures that perceive radio waves directly and we don't. And they have their science, and they come to Earth and they notice us, moving around, doing various things. So they decide to study the brain. And they take the brain apart and they see how it works and how it functions. Now, there's a lot going on in the brain that isn't accompanied by experience. Only certain parts of the brain are associated with conscious experience. Much of it, like what determines your heartbeat. You don't decide that your heartbeat should go up or down. You could think about something scary, but you don't think, I'll push my heartbeat up or down. A lot's going on in the brain which is unconscious. Now, this creature is looking at the human brain, taking it apart. He sees how it functions. When the eyelids are open and light rays hit at the retina, then these circuits are set up and those circuits go out. And the circuits result in behaviors. They are instinctive behaviors also. Somebody bangs your knee and your knee goes out. You didn't make it go out. You didn't choose to go out. It goes out by itself. First time it happens to you at the doctor's office, you're surprised. Why did it go out? I didn't make that happen. Lots of things happen that are not caused by experience. How would that creature know which things going on in your brain are accompanied by experience and which not? How would it know that? How would it discover that? What would it look for in the brain? What telltale source would it look for in the brain to say, aha, that one is experienced and that was not experienced? We can say, because we ask people what they feel. We ask them what they're experiencing. We set up correlations. But if you're just looking at the brain, in the brain itself, if the brain is the experience, then there ought to be some telltale structural thing in the brain itself that says it's an experience. It seems like that's beyond belief. There's just nothing there to do that. That's why we always rely on reports of the experience by the person whose brain you're looking at, so as to be able to set up the correlations. Now, a more extreme version of this idea, this was common in philosophy in 70, 80 years ago, then it died out for a while. It's been restored by David Chalmers, among others. They're talking about zombies. Okay, this is not horror movies. A zombie in philosophy is a creature that looks just like you and me. Talk to him, talks back, behaves, yells in pain, eats, drinks, catches a cold, just like you and me. If you look at his brain, this is very important now. If you look at his brain functions just like you and me. The only difference between us and a zombie is a zombie has no experience. It's blank in there. Blank. He's just got the functioning brain without any experience. Now, here's the question. Are zombies possible? Is such a thing possible? I want to tell you how prejudiced philosophy is. About 60, 70 years ago, one of the big problems in philosophy, one of the big questions was, how do you know that everybody else isn't a zombie? How do you know that you're not the only person having experience and everybody else just behaving, just a machine without experience? How do you know that? It was a big problem in epistemology, study of knowledge, and people put forth arguments, people rejected the arguments. That whole exercise, decades long, took for granted it was possible. Of course it's possible. And because it's possible, we want to know, how do you know it isn't true? All of a sudden, when materialism took over, and when this became an argument that experience isn't the brain, all of a sudden, a lot of philosophers said, no, that's not possible. That couldn't be. That's impossible. So you can't take that seriously. How come? Because now it costs. Now the idea of a zombie has a cost. Because here's the cost. If a zombie is possible, then the materialist loses right away. He loses right away. Let's go through it again. The materialist says that the toothache is nothing but a brain process. It is the brain process. That means if somebody's brain functions like mine, he can't be without experience. It can't be. Because the toothache is what goes on in the brain, and it's going on in his brain, so he must have a toothache. That means zombies aren't possible. If zombies are possible, then the toothache can't be in the brain. Because a zombie is someone whose brain looks just like mine. It functions just like mine. He just doesn't have any experiences. If that's possible, then the toothache can't be in the brain. Now, how are you going to argue it's not possible? Not possible? Not actual, not real? Fine, but not possible? Certainly it's possible. That, for many, has been taken as a cut. You can't say it's in the brain because if it were in the brain, zombies would be impossible and zombies are clearly possible. That's one type of argument that's given. Are we got it so far? Well, you'll have 23 hours to think this all over, and we'll go back over it again tomorrow. Here's another argument. This argument was given by a fellow named Frank Jackson. Ironically, after giving the argument, publishing it, some years later, he took it back, and he decided that he was no longer in favor of the argument. So there's Frank Jackson 1 and Frank Jackson 2. And there are some people who think that the Frank Jackson 1 is more convincing than Frank Jackson 2, and then are following him with the rejection. But here's the argument. Argument considers Mary a super smart neurosurgeon. Mary was born in a black and white environment and raised entirely within a black and white environment. She's completely normal, but all she's ever experienced is black and white. No colors. Mary becomes a neuroscientist. And she studies, in particular, vision. From the retina all the way up through the optic nerve to the optic center in the brain. And she knows it cold. She knows exactly what happens in the brain whenever light rays hit the retina. If the light rays of a certain hue, then it interacts with the rods in a certain way, rods and cones, and it triggers certain impulses, and she's got it all mapped out. She knows everything that goes on in the brain concerning vision. Okay? Now, one day, she's let out of the black and white environment, and for the first time in her life, she sees a red rose. For the first time in her life, she sees something red. Does she learn something new when she sees something red? The overwhelming intuition that people have until they get polluted by philosophy is, of course, she now knows what red looks like. Before now, she knew exactly what red does to the retina, the optic nerve, and the brain. But she doesn't know what it looks like. Now she knows what it looks like. Well, if that's right, then the experience of seeing red isn't an event in the brain, because before she went outside and saw red, she knew everything about the brain. There isn't anything new for her to learn about the brain. The brain is totally contained within her knowledge. If she learns something new when she looks at the red thing, she learns what red looks like. That new fact, what red looks like, isn't a matter of what's going on in the brain. Because before she learned it, she knew everything that was going on in the brain. And since that story also seems to be perfectly reasonable, perfectly possible, it becomes very difficult to accept the idea that that what red looks like, the experience of red, is just something that goes on in the brain. Are we together? And these are principled arguments against the idea that the experience is in the brain. Then there's another one. It's an idea pushed, the general idea is pushed by Thomas Nagel and John Searle. John Searle thinks he has a way out, and Thomas Nagel doesn't agree with him. Now, this is a little subtle. I'll do the best I can to explain it. If you have an experience, any kind of experience, I can ask you, what's it like? What's it like? How does it feel? Toothache, vision of a red rose, perception of a red rose, hearing Beethoven violin sonatas. What's it like? What does it feel like to you? Experience has a to you built in. An experience is an event that happens to a subject. There's a subject who has the experience. the subject who's registering experience. If you imagine something happening without a subject, there's no you, there's nothing there to be felt by, then it's not going to be an experience. Imagine pain, but with no one in pain. There's no one in pain. No animal. There's nothing that's in pain, just pain. Doesn't make any sense. Pain is something suffering pain, something feeling the pain. Experiences have a you for whom it's an experience built into its structure. That's part of what an experience is. Now, someone's suggesting that we build experiences out of cue. We've got cue parts all around, and with things, you put the cue parts together the appropriate way, then we're going to get an experience. Well, if the you, the subject, is built into the experience, when you take those cue parts and start assembling them and building them up and making them more and more complicated, you better have some way of getting a you into the ensemble. You better have some way of building a you into the combination. If you don't, it's not going to be an experience. If you're not going to get a subject in this ensemble of cue parts, then the cue parts are not going to be satisfactory to give you an experience. All right, let's now try something really simple. Let's try bricks. Bricks. Build a structure of bricks. Lots and lots of bricks. Oh, that sounds silly. That's because you haven't tried 1.5 billion bricks. You haven't tried that. You haven't tried that. You haven't had a big enough grant to the American Army to take 1.5, but I'm telling you, 1.5 billion bricks, that's worth a try. You think we're going in the right direction to get 1.5 billion bricks, and inside the 1.5 billion bricks, there'll be an experiencer, a subject for whom this is an experience? Bricks don't make subjects. Bricks don't do that. You can have 2 billion or a trillion. Bricks aren't going to do it. They're the wrong kind of thing to build up a subject that's having an experience. Sand. Shall we do it with sand? Sand particles are very small. They're very, with such small particles, you have a lot of flexibility, the shapes and everything else. Sand with a little glue, glue them together and make shapes out of it. Are you going to get a subject, an experiencer out of just grains of sand? Doesn't look like it. It's the wrong kind of material to give you an experiencer. Okay, how about electric wires? Electric wires. Lots and lots and lots of electric wires and transistors and capacitors and batteries and so on and so on. 1 billion of them. You never tried 1 billion? Maybe we should get a scientific grant and try it. How can you say no if you haven't tried it? The answer is because I can see that it's the wrong type of stuff. Same thing's true with neurons. Neurons are the wrong type of stuff to build up a subject that has experiences. It's the wrong kind of material. Some projects aren't worth investigating because intuitively or logically, they don't make any sense. Now, again, this is not infallible. Something that didn't make sense 200 years ago could make sense in the future. But in the meantime, when it doesn't make sense, you don't pledge allegiance to it and say it's surely correct. You say maybe in the future, to our surprise, it'll be proven correct. You don't pledge allegiance to it now. It's the wrong kind of project. Building up experience out of neurons where the experience has to have this dual structure. There's the subject having the experience, and it's the quality of the experience. Neurons they don't contribute to an experiencer having the experience. They just don't do that. So again, we have a reason in principle that this kind of project of finding the experience in the brain is not going to work. That being the case, I think the person who claims that experience is in the brain really has no support for his view. He has no support for his view. And that being the case, at the very least, if he's honest, he ought to say, maybe I prefer it, and maybe it's my chosen research model, and so on and so on, but to pledge allegiance to it as obviously correct, established by modern science? It's simply not true, simply not correct. Questions? Okay, now as I said, tomorrow I'll go back through all of this and I'll do it again. You'll have a chance to hear it again. But the next obvious question is, well, then why are they convinced about it? Why are so many people tell you that they're convinced about it if they don't have good reason? Now, I just want to remark that that kind of question should be taken with a cupful of salt. Lots and lots of people believe things for no good reason at all. Even if they're sophisticated and educated people, they believe things for no good reason at all. I have a motto: don't count people, count reasons. 1 billion people with one reason, count for one. One person with 3 reasons counts for 3. Don't count people, count reasons. My emblem of this is anti-Semitism. What would you say there are more of in the world, Jews or anti-Semites? Yeah, that's not a hard question, is it? At least hundreds of millions of anti-Semites, maybe more. Could they all be wrong? All of them? Does this make it hard for you to sleep at night? Maybe we really all are intrinsically evil, all of us, because there are hundreds of millions of people who say so. I hope it doesn't make you feel bad, make you feel nervous, because if you ask them what their reasons are, they don't have any good reasons at all. If they have no good reasons at all, I could dismiss the hundreds of millions. I want you to know that in Germany, at the end of the 19th century, beginning of the 20th century, in universities, there were fraternities where you could not join the fraternity unless you signed a document that you were an anti-Semite. Being an anti-Semite was a ticket of admission to the fraternity. These are university students. They're not coal miners, not cab drivers, university students in Germany. So the fact that a person is smart in another area doesn't mean he can't be prejudiced in this area. And that's why I say to the scientific profession, give me your reasons. I want to see your reasons. If you have good reasons, I'm happy to at least say you're reasonable and I have to treat you with respect. If you don't have good reasons, not. The fact that you call yourself a scientist is not good enough. So that's the bottom line up to here. The fact that so many people believe it, they may believe it. I can give you some speculations about the reason. We'll talk about that tomorrow. But in the meantime, the fact that they believe it alone should not shake you. What you should say is, tell me what your reasons are. Now, the last thing in this regard, people talk about experts. Shouldn't you trust the experts? Here, I think that it's a split ticket. There are 2 types of experts. One type of expert is a person who just knows a lot about the subject. He knows a lot about it because he studied it. I haven't studied it. If that's the way he's an expert, he ought to be able to communicate to me what his reasons are. He knows. Let him write a book and summarize what he knows and show me what he knows. Then I can make up my mind whether the reasons are adequate or not. He may know a lot about bullfinches. That doesn't make him a superior logician to me. He knows a lot of facts about bullfinches I don't know. Let him put them in a book and I can use my own logic to decide whether his conclusions are reasonable or not. Another type of expert is a person who's mastered a field that is inherently so complicated, so complex, and so difficult that it requires years and years of study to become conversant with the subject, to be able to say you understand what the evidence is, like higher mathematics. There, I'm inclined to think one should trust the experts because I have no access to it. I can't form a judgment of my own. I can't follow the reasoning. It's too complex for me. Here, the evidence that they are appealing to is evidence that everybody can understand. In general terms, you can understand the quality of the evidence, and you can make up your own mind. It does not require detailed scientific expertise, sophisticated scientific expertise to read the evidence and see what the survey of the evidence is and see how it works. One of the books in critique of evolution was written by a fellow who was a professor of law at Berkeley. And he said, the truth is, I don't know anything about evolution, but I know about arguments. I know about evidence. I know about proof. That's my expertise. And you show me the evidence that you're using to support your case, and I'll decide whether it's logically binding or it isn't logically binding. And that was a perfectly rational approach. Because in evolution also, it's not higher mathematics. It's material that's been amassed and evidence that's been correlated. But anybody can read it and get the understanding of what type of evidence it is, and then you can apply your logic to it. Okay? We'll pick up with this again tomorrow.